All right, well, here we go. Hey, look, it's good to catch up. Just for the benefit of anyone else, if those of you listening, Julie and I have sort of gone back about 15 years, and I've long been interested in Julian's research. It's amazing research looking at this thing called HRV, which is just now sort of getting some prominence, and sort of becoming better known. I've been fascinated by some of the things that you've revealed about its predictability, its amenity for intervention. So I thought before we sort of get started, maybe you could just give us sort of a quick little introduction of just what is HRV,
Yeah. Well, heart rate variability, HRV, is the variability in the timing between heartbeats. And, when you go to your general practitioner, sometimes, or a cardiologist, they may talk about what they call regular sinus rhythm.
Yeah, okay.
And, and they look for a regular sinus rhythm.
Correct.
But the reality is that the more variable it is, generally speaking, the better. So it's not a regular, like metronomic beat, but one that, fluctuates over time. And this variability is due to both a neural and mechanical gating of the vagus nerve.
Got it.
So again, there's a phenomenon called respiratory sinus arrhythmia.
Mm-hmm.
When you inhale, your heart rate tends to increase. When you exhale, it tends to decrease.
Okay.
And that has to do with both, like I said, the mechanical, because of the change in thoracic pressure, and neural gating of the vagus nerve.
Okay.
So this vagus nerve is the longest nerve in the body.
Yep.
It's been known to be important for centuries.
Got it.
And in fact, Darwin, in a book that is not his most famous book, but one for researchers is very famous, called Expression of Emotion in Man and Animal.
Yes.
He talks about the connection between the heart and the brain via the vagus nerve, known at that time in the 1850s as the pneumogastric nerve. Pneumo, gastric, gut.
Okay.
Because there are sort of two branches of the vagus nerve, one that goes to the upper thoracic area and one that goes to the lower subdiaphragmatic area.
Got it.
So he talks about this.
Yeah.
Now, what's interesting is that this is about a 600-page book. So this is on page 72, more or less.
Yeah.
So this is the basis of his work on expression of emotion in animals, not the conclusion.
Interesting.
Yeah.
Yeah, okay.
And he's talking about the work of the French physiologist Claude Bernard, who some people call the father of modern neuroscience, because he's been studying these things. So they noticed this connection between the heart and the brain. And to this day, I have no idea how they figured it out.
Amazing.
So, because think about what we knew about the heart in the 1850s. Think about what we knew about the brain. Think about what we knew about nerves. More or less nothing.
Got it.
And they proposed this very specific pathway between the heart and the brain via the vagus.
Okay.
And my current theory is that it's aliens.
That's a good theory. Yep. Okay, good. It just works.
Yeah, because I can't figure out how they had that
insight.
Incredible insight. Exactly.
Amazing.
Yeah. So the interesting thing about the vagus is that until relatively recently, trying to get a measure of the activity of the vagus nerve has been very difficult to do, let's say, non-invasively.
Got it. Okay.
So in sort of the late 60s, maybe early 70s, they started to see, looking at fetal heart rates.
Yes.
And they saw that when the fetal heart rate became steady, that was a bad sign for the infant. For the fetus. And so the early work on heart rate variability was, in fact,
looking at babies.
Yeah.
Whoa.
So then they realized that having a more variable heart was associated with better birth outcomes.
Isn't that interesting?
Right. So that's kind of the beginning
Genesis
of sort
of it,
right,
yeah,
modern
okay.
heart rate variability.
Interesting. And so we've got this thing called the vagus nerve, and it's wired into, obviously, it's the wiring between the brain and the heart, and it's also the wiring into lots of other organs as well.
Exactly.
And you know, some of the literature talks about the sort of the vagus nerve as the brake, you know, for
That's
sort
right,
of like
the vagal brake.
yeah, there we
That's
go.
like Stephen Porges's terminology.
And there's this sort of idea that, you know, we've obviously got a parasympathetic system and a nervous and a sympathetic nervous system, and the vagus nerve sort of connected with the parasympathetic nervous system, right?
Yeah.
Exactly. Okay.
So the vagus nerve itself is thought to be the largest nerve in the body. It's about 80% sensory in humans.
Yes.
It varies from species to species, but it's about 80% sensory in humans, which means that there are receptors on the vagus nerve throughout the body for all kinds of substances, glucose, pro-inflammatory cytokines,
Got it.
cholesterol.
Yes.
There are pressure sensitive ones that are associated with blood pressure and gut distension. So all these signals go via the vagus nerve to the brain.
Got it.
And then they go into an area called the nucleus tractus solitarius.
Mm-hmm.
And this area of the brain has several subnuclei. And what's interesting, it has what's called a somatotopic organization. So that where the nerves come into that nucleus tractus solitarius tells the brain where those signals are coming from.
Got it.
And so there's several nuclei, I think at least 5.
Yep.
Let's say one for the gut.
Yeah.
One for respiration.
Yes.
One for the cardiovascular system.
Got it.
And they're all separate but overlapping.
Yes. Got it.
And within this nucleus tractus solitarius, there are interneurons between the different subnuclei.
Uh-huh.
So it does sort of pre-processing of the signals before it sends it up to the rest of the brain.
Amazing.
Yeah.
Okay.
Yeah. And all the way up to the prefrontal cortex.
Got it.
So this allows the vagus nerve to be an indicator of a lot of different functions in the body.
Oh, because that's kind of, we're going to get to that sort of little piece. I mean, I've obviously had years to ingest your research, and over the years of conferences, I've seen these amazing outcomes that have been reported that interventions to improve HRV can improve brain mass.
Right.
They can predict mental health outcomes. They can predict cardiovascular outcomes, and for the sort of down initiated, it starts to look a bit like magic.
That's right. Exactly.
Yeah.
Exactly.
Yeah.
And that's why it's important to understand that underlying physiology.
Yes.
Why this is the case.
Yeah.
So some people say that the vagus is part, and they call it the vagal nervous system.
Got it.
Is a system that is a psychophysiological indicator of the status of the organism.
Okay. So that starts to make a bit more sense, doesn't it?
Right.
And for me, when I have these conversations, I've drunk the Kool-Aid. But it's a real challenge to sort of articulate that nice and clearly. But I think sort of having that sort of physiological sense that it's unifying as a sort of control mechanism for the body systems is reassuring when it starts to come to that sort of its predictiveness.
Right.
Further down the track.
Exactly.
Yeah.
And I tend to think of the vagus as kind of a sentinel. It's keeping watch on the status of the organism interacting with the environment.
Yes.
And it sends signals to the brain to try to produce what I call context-appropriate responses.
I got it.
Because, trying to match your response to the environmental challenge that you're facing.
Yes.
And any mismatch, that's my sort of definition of stress. If you have a prolonged response after the situation has changed and you're still responding in a wrong way,
yes,
or you cannot mount an appropriate response to the challenge.
Okay.
That I view as stress.
Got it. Got it perfectly. So I mean, I get to see some of your papers, which is a real treat, and the diversity of them is always fascinating. I want to start looking at this HRV as a health predictor.
Yeah.
Because we've seen, you've recently done work showing that low HRV is clearly associated and predictive of poor mental health. There's work that sort of that's very clearly articulates low HRV with chronic cardiovascular poor health. We've also seen work that it shows it's highly correlated with all-cause mortality.
Exactly.
Yeah. So, Matt, perhaps you can talk to some of the. I've done a very butcher's job of expressing it, but just some of the high points for you in terms of what you think its predictive power is. Yeah.
So, because it's an indicator of the psychophysiological state of the organism.
Yes.
It allows us to make inferences about various processes going on in the body.
Got it.
And the vagus is associated with the parasympathetic nervous system, which is the rest and digest system.
Got it. Whereas
the sympathetic is the fight or flight system.
Got it.
So in this context, a lot of the activities associated with fight or flight are indeed under tonic inhibitory control by the vagus. So if you cut the vagus nerve, your heart rate goes up, blood pressure goes up, glucose goes up, cholesterol goes up, inflammation goes up. So all those things, for example, are under tonic inhibitory control.
Got it. So the vagus is down-regulating them. Got it.
Right. So that's kind of the idea of the vagal brake in some way.
Got it.
So if you think of, the sympathetic fight or flight as the accelerator in your car, and the vagus as the brake in your car, the rest and digest.
Yeah.
It's one thing to have a car that can go very fast with a full tank of gas and everything, but that's helpful. But if you can't stop the car, you're in trouble.
Yeah, it is.
So you gotta have good brakes.
Yeah.
And that's what a good working vagus allows you to do, is to produce those fine-grained adjustments to environmental challenges so that you produce a response that matches the energy demand of the situation of your.
Cool. So if we've got low HRV predicting poor mental health, or low HRV predicting poor CBD outcomes, how specific can we be about those things? So let's start with the mental health one. Tell us what those sort of insights look like.
So our group and others have shown an association between various measures of heart rate variability, particularly the so-called high frequency, which tends to be more vaguely mediated heart rate variability.
Yep.
And all kinds of disorders. So in the mental health area, they're typically grouped into sort of three categories: internalizing disorders, externalizing disorders, and thought disorders.
Yes.
So internalizing disorders are like depression and anxiety. Externalizing are like alcohol and drug abuse, and thought disorders are like schizophrenia.
Got it.
And we and others over the years have shown heart rate variability to correlate with all of those: internalizing, externalizing, and thought disorders.
Okay.
And in general, lower heart rate variability is associated with poorer of those mental health outcomes. Okay, so that's just correlation.
Right.
But it's also been shown that heart rate variability predicts the development of some of these disorders years into the future.
Interesting. Okay.
So individuals with low heart rate variability, let's say at time 0, are at greater risk at T1, whatever that might be.
Yes.
2 years, 5 years, maybe we've done studies at different time ranges. They are at increased risk for developing these types of mental health problems.
Okay. And so now I want to ask the same question in cardiovascular disease, because after this, we're going to talk about interventions and how we can change the course of things.
Exactly.
Yeah.
So similarly,
Yes.
we and others have shown correlation
Yes.
between heart rate variability and other biomarkers that are used to index cardiovascular disease, like blood pressure, cholesterol, inflammation, glucose. So those
It's a lot there.
right.
Yeah.
Exactly.
Yep.
It sort of covers the waterfront.
It does really, doesn't it?
And so those are sort of correlational studies.
Yes.
But then again, these prospective studies also show that heart rate variability predicts these things, let's say, again, from time 0 to time 1, whatever that might be.
Yeah.
So I'll just give you one example. We've published a couple of papers showing that heart rate variability predicts blood pressure 6 years later. So those with higher heart rate variability, time 1, have lower blood pressure 6 years later.
Amazing.
Right.
Okay. So that's pretty clear, right?
Yes.
And similarly, you've looked at all-cause mortality as well, haven't
Absolutely.
you? Yeah.
Yeah, absolutely. So again, it's interesting that it's not, even though it's a cardiovascular function that we're measuring,
Yes.
it's not just cardiovascular mortality that's predicting.
Yeah,
It's predicting all-cause mortality.
Yeah. Far out.
Yeah.
Yeah.
Yeah. And again, we've done several studies, including some meta-analyses, showing that your risk of mortality is about 56% greater if you're in the lowest quartile of heart rate variability compared to the other.
That's a big number, right?
Yeah.
Yeah, that's not a small thing.
That's right.
Yeah.
So it's comparable to the effect of, let's say, sitting for 10 hours a day.
Yes.
It's similar in size to the effect of having white coat hypertension
Okay.
in predicting mortality. So these are not
They're not like small inferences.
exactly.
Yeah. It's really, really clear.
Yeah.
It's obviously, a new science. We've had Framingham for as long as we've had it, and so they're very, very familiar. Do you see a world in which sort of HRV is going to be a useful screener?
I think so. So, for example, talking about Framingham, we published a paper showing the correlation between heart rate variability and Framingham risk score.
Yep.
So, that's used as a predictor.
Yes.
And we show that they're correlated.
Yeah, good.
Yeah.
Okay.
So, I can imagine that heart rate variability could be used for risk stratification.
And that's what's interesting for me, because I look at health risk assessments and what they look like. And also, I'm really conscious in the world of occupational health and employee health. There are real costs associated with doing those assessments,
Absolutely.
and they can be quite burdensome costs.
Right.
Yeah. But, and they're inaccessible. There's plenty of people who opt out of them. They might be people who work on the road and can't get into a doctor's practice and those sorts of things.
Exactly.
Yeah.
So this type of measure, can be even potentially like a pre-screener.
Yes.
That is to say, before you do all that more expensive assessment, you have a relatively low cost tool that can indicate people who are at greater risk for these other problems before having to go into all the detailed and more expensive assessment.
Yes, absolutely.
And again, in a sort of a occupational context, individuals that have low heart rate variability report poorer self-rated health.
Yes.
And that's been linked with, absenteeism from work.
So
there's economic costs associated with it.
Yeah, absolutely. I think I can't help myself. I always find that I always get to the fact that it's so interesting with HRV that there is actually a reasonably simple intervention to improve HRV.
Yes.
And when I think the most exciting, when I've been most excited about your work is when you've shown a simple intervention over a short time having sometimes profound impacts on people in a very, very short period of time.
Exactly.
So, there was if we think about high blood pressure and its amenability to intervention, or high cholesterol and its amenability to intervention, they're actually expensive, time-consuming, and the change over time is reasonably low.
That's right.
Whereas with HRV, we can see that it's very amenable to intervention. People can do the intervention. The results are significant as a result of it, both in change of HRV, but also in terms of health status as well.
Exactly.
So can you take us through, I think, and we've got a long list of them, but if you can take through maybe sort of a few of, you think of some of the high points of some of the interventional outcomes you've seen, and then we'll get to what the intervention is afterwards.
Yeah.
Yeah, is that right?
So there are lots of different, well, let me take a half step back.
Yeah.
So heart rate variability is partially heritable.
Yes.
And partially associated with, let's say, environmental factors.
Got it.
Okay. So in our behavioral genetic studies, we show that about heart rate variability is about 50% heritable.
Got it.
Which means it's 50% amenable to change.
Got it. Thank you. Mm-hmm.
Right?
Okay.
Okay.
Yep.
So, and in our molecular genetic studies, we've identified particular genes associated with it, that kind of thing. Interesting. Okay, so that's sort of on the genetic side. So the fact that it's a modifiable risk factor.
Bingo. Thank you.
Makes it particularly useful, I think.
Yeah. Okay.
Okay. So how can you modify it?
Cool.
And so there are, more, let's say, intensive ways of modifying it.
Mm-hmm.
Regular physical exercise.
Yes.
One of the main outcomes associated with increased physical activity is a lower resting heart rate.
Yes.
And that's basically under vagal control.
Got it. Thank you.
Okay. And studies have been done that show that, an exercise program will increase your heart rate variability. And when you stop the exercise program, your heart rate variability goes back down.
Okay. Got it.
Okay. But, exercise is not for everybody for various reasons.
Yes.
So then there are dietary ways in which one can influence heart rate variability.
Yes.
Not only what you eat, but when you eat.
Fascinating. Go on.
So we've done studies where we've given people salmon 3 times a week for 6 months.
Yeah.
And see improvements in their heart rate variability and in their mental health, physical health.
Okay.
Okay. So that's another type of intervention. Again, related to diet, my former colleague from the National Institute on Aging, Mark Madsen,
yes,
has studied caloric restriction,
yes,
and meal frequency.
Yes.
And there's this phenomena of sort of intermittent fasting that's become popular these days.
Yep.
So he has a nice review paper in New England Journal of Medicine talking about the effects of sort of caloric restriction and intermittent fasting.
Yep.
So one way to do that is to sort of restrict your caloric intake to a more or less 6-hour period in a day.
Yes.
Okay. So that's another way to potentially increase
HRV as well.
Yeah.
Okay. Okay. So all the good things that we'd expect that are already been proven to have health benefits, also express those benefits as improvements in HRV.
Exactly.
Okay.
And then there's yoga, stress reduction types of thing.
Yes.
And that starts to get into an intervention that we're particularly excited about, which is this breathing, slow breathing intervention.
Awesome.
And so we've done a couple of trials now.
Mm-hmm.
One completed, one that we're in the middle of.
Yes.
Where we more or less train people to breathe at about 6 breaths per minute.
Got it.
And in our first trial, which was breathe about 30 minutes a day for 5 weeks.
Yes.
5 weeks.
Not a long time.
Not a long time.
Yep.
And we had a group of younger individuals and older individuals.
Yep. So shorter than your average diet, right?
That's right.
Yep.
Exactly.
Yep.
Exactly. And we found some pretty amazing things.
Go on.
So as you kind of alluded to earlier, increases in prefrontal cortical thickness.
How much?
I can't say in terms of actual cortical thickness metric.
Yeah.
But what I can say is that there's an idea
Yes.
that humans are a self-domesticated species.
Okay.
And what happens, so there was a study done by my colleague Mats Fredriksson in Sweden
Yeah.
in rabbits.
Yes.
And he showed with domesticated rabbits compared to wild rabbits, the prefrontal cortex gets bigger and the amygdala gets smaller in domesticated rabbits.
Okay.
And they show less of this fight or flight response. And, of course, become pets.
Got it.
Okay, compared to the wild rabbits.
Interesting.
So this cortical thickness is associated with feelings of safety and that kind of
Stability. And
Exactly.
so what we're saying is you can see a significant increase in cortical thickness in humans
Right.
as a result of these breathing
right,
exercises.
in an area that's associated with well-being.
Thank you.
Yeah.
Yeah, okay.
Okay.
Yep.
So so we see these changes in cortical thickness. We also see changes in the relationship with the amygdala.
Okay.
So the functional connectivity.
Yes.
And we're working on have a paper we're about to submit where we also show it's related to similar to what they found in rabbits, prefrontal cortex size, amygdala size, inversely correlated.
Interesting.
Right.
Absolutely fascinating.
So this is all just sort of the structural, and then there's, like I said, the functional connectivity
Yes.
between the prefrontal cortex and the amygdala and these other emotion regulation regions in the brain.
Got it.
Associated with this breathing intervention.
Okay.
Interestingly, and somewhat surprisingly, we found huge effects on amyloid beta levels, which is the stuff that's associated with Alzheimer's disease.
Absolutely.
And that allowed us to get funding for the second trial where we're going to explore that more closely. But basically, those individuals that were doing this 5-week intervention, they showed significant and large decreases in amyloid beta levels.
Well, I've got some people who'd love to know what large looks like. You and I've talked about this. It's like about a standard deviation.
Exactly.
Yeah. Okay.
Yeah.
And, if we went around people in their 50s and 60s and said, would you like to decrease your chances of developing amyloid beta plaques in your brain by 35 to 40%, would you be interested in that, knowing that it would only take 5 weeks?
Yeah.
That's pretty compelling, isn't it?
Yeah, exactly.
And out of all the things that you can do, there's a Dale Bredesen and people like that looking at sort of the multifactorial ways in which dementia risk can be sort of down-regulated.
That's right.
It's a pretty simple intervention compared to a lot of them, right?
Exactly. And this is what's so exciting about this work that we've been doing with my colleague Mara Mather at the University of Southern California.
Yeah, okay.
So we've been working together for more than 10 years now.
Yes.
She's just brilliant and she has a great team.
Awesome.
Yeah. So we're so that breathing intervention.
Yep.
So the example that I sometimes give, I ask people, well, how long can you survive without food?
You quite a long time, right?
Yeah.
Yeah, as long as you get the water, you can months and months.
Right.
Yeah.
How long can you survive without water?
Yeah, 3 days maybe.
More or less 7.
Yeah, okay.
Yeah,
It's in that order. Yep.
right. But how long can you survive without breathing?
Yes, exactly. About 6 minutes. Yep, I get it.
Okay.
Yeah.
So breathing is something that you have to do.
Yeah.
If you don't do it,
Yeah, you die.
you die.
Yeah.
And since it's something that is so mandatory,
Yes.
and you're doing it anyway.
Yeah. Why not slow it down?
Right.
Yeah.
If you can do it in a way that helps to produce better health outcomes.
Yeah.
It's a relatively low barrier to implementation.
So let's talk about, have we studied other sort of health benefits like cardiovascular benefits associated with these sorts of, with a similar intervention?
Yeah.
Yeah.
So, for example, we've found this type of intervention reduces levels of pro-inflammatory cytokines.
There we go.
Which are, of course,
people pay lots of money for supplements and medicines that do exactly the same thing.
Exactly.
Yep.
Exactly. And not in our trials per se, but in other trials, that's giving things such as lower blood pressure as well.
Yeah. Okay. So let's just talk a little bit about the mechanism of action for the lower blood pressure. Explained this to me recently, and I had an aha moment when I sort of understood that. So yeah, if you could sort of share with us, I think it's really helpful.
Yeah. So I think it helps to have a little bit of background on what we know about blood pressure.
Got it?
So, at least in the U.S., there's the idea that long-term blood pressure, the major determinant of which is fluid volume.
Got it?
So this suggests that salt intake, which is associated with increased fluid retention,
Yes.
is maybe a driver of hypertension.
Got it. Okay.
So this is based on a model from Arthur C. Guyton from the University of Mississippi.
Yep.
Who half a few years ago.
Mm-hmm.
But so this was based on a particular animal model, and despite many years of the group there trying to validate this model, the data is not so good.
Okay.
For one thing, hypertension is a multidimensional thing.
Yep.
And so for some people, fluid volume may be associated with hypertension.
Okay.
But increasing evidence, well, even before this studies from Guyton in the 70s, I think it was, and then now accumulating evidence after those studies, suggesting that, well, actually, the major determinant of long-term blood pressure is your barrel reflex.
Okay.
So Guyton's model states that the barrel reflex reset too quickly for it to be associated with long-term blood pressure, but that might have been a function of the particular animal model that he was using. So other people have shown, well, that's not necessarily so, and even people from Guyton's own group are starting to say, well, the barrel reflex may be more important.
Yeah.
Okay. So in that context, then, the barrel reflex is another sort of, there are different ways of measuring the barrel reflex.
Yeah.
And there are different, let's call them limbs of the barrel reflex.
Yes.
So one limb, and this is one that's most commonly studied, is the relationship between blood pressure and heart rate.
Got it?
So that might be called the cardiac limb.
Yes.
Then there's the relationship between blood pressure and cardiac contractility or stroke volume.
Yes.
Okay, that might be considered the myocardial limb.
Okay.
And then there's the relationship between systolic blood pressure or blood pressure, let's say more generally, and that peripheral vascular resistance, total peripheral resistance. And that would be considered the vascular limb.
Okay. Now I'm getting it. Yes.
Okay. So the cardiac limb is very much highly correlated with heart rate variability. So this is also an indicator of vagal function.
Got it.
Because the vagus is part regulating that beat to beat variability in blood pressure.
Got it.
That the barrel reflex is regulated.
Okay.
So that's sort of the physiology of the relationship between heart rate variability and blood pressure.
Got it.
Similarly, in our molecular genetic studies, we've shown that the genes associated with heart rate variability are also associated with blood pressure. So higher heart rate variability is associated with lower blood pressure, and there's some common genes that
Part of that. Okay.
so the genetic correlation between heart rate variability and blood pressure is there.
Okay. Interesting. Okay. So thinking about this intervention, so we now know that we've got a breathing intervention with as little as, sort of anywhere between 10 and 30 minutes a day. People can have a significant health benefit. We can see it in terms of lowering their blood pressure, like we've just talked about. We can see it in terms of impact on mood as well, can't we?
Exactly. So we've shown that this type of intervention is associated with improved mood.
Yep.
Measured with different types of measures of mood that are associated with things like depression and anxiety.
Yeah.
And interestingly, the magnitude of those heart rate oscillations, the greater the heart rate variability that you achieve during your breathing,
Yes.
it seems to be the driver of this.
It's really extraordinary, isn't it? Yeah. When you do your studies, with people doing the slow-paced breathing, are people coming into the lab or are people doing that at home?
So we bring them into the lab for sort of first session.
Yes.
And we also do neuroimaging. So that's the part that clearly has to be done in the lab.
Absolutely.
Then we send them home.
Yeah.
And they do this at home. They do the breathing intervention, the training at home.
Cool. I was thinking, we've talked about cardiovascular. You've also done work to show cardiometabolic benefits as well, haven't you?
Yeah.
Yep.
Yeah. So
glucose control.
Exactly.
Yeah.
Exactly. And again, there was both cross-sectional, correlational, and prospective studies suggesting that higher heart rate variability is associated with better glucose control.
Yeah, so I guess the point is like we know that we've got dietary interventions, we know we've got medical and nutritional interventions, but really, it's a real case for breathing being part of the mix, right?
Absolutely.
Yeah.
Absolutely.
Okay.
And because you have to do it.
Yeah.
If you just take some time out of the day to do it in a particular way.
Yeah.
It can have just enormous benefits.
It's amazing, isn't it? Yeah. Okay. Is there been any sort of inquiry, like, where you've done it as an intervention, specifically for, people experiencing, say, depression or anxiety or something like that?
So we have not looked at clinical populations per se.
Yep.
In another trial that we did in Germany,
yes,
we looked at patients with COVID.
Yes.
And in those patients with COVID, the breathing intervention decreased their IL-6 levels.
Okay, so straight down regulation of inflammation.
Right.
That is not a small thing.
Right.
Yeah. Okay. Yeah.
So, these types of interventions, you're trying to nail down the mechanisms and the parameters that may yield. Actually, I have to correct myself.
Yeah.
We did one study with this type of breathing intervention with patients with psychotic symptoms.
Yes.
And it improved their symptoms.
Unbelievable. Yep. Okay. Wow. Yeah. I suppose it feels intuitively right because, when we up our HRV, one of the things that, you and I've talked about is that there's a really high correlation between how people say they feel and their HRV, isn't there?
Exactly.
Yeah.
So, we did that study some years ago with Yal Benjamini, who's one of the world leading experts on self-rated health.
Yes.
And we showed that heart rate variability is more highly associated with self-rated health than a whole range of other biomarkers, levels of inflammation, glucose, cholesterol, blood pressure.
Well, because, and we look at blood pressure and no one can feel the difference between, 120/80 and 190, over 140. So,
Exactly.
Yeah.
Exactly.
Yeah.
So, the silent killer of hypertension.
Yes.
It's called that for a reason. You can't notice it. That's why you need to monitor those types of things.
And yet here we have a measure that people are able to, say that it's highly correlated with HRV. The point being, we also have an intervention that makes them feel better.
Right.
Okay.
Exactly.
So now if we have something that we know lowers blood pressure and makes you feel better, so people can actually feel the benefit of this, because I suppose they feel, objectively, I would say people who do these kind of interventions would sort of self-rate as that they've just got more regulatory capacity or self-regulatory capacity in their day, don't they?
That's right.
Yeah.
And again, in a series of studies with Jos Broschard,
Yes.
we have shown that the more you worry, the lower your heart rate variability.
Got it?
The more you worry, the more symptoms you report.
Yes.
So, and if you have higher heart rate variability, you worry less and report less symptoms.
Okay.
Right.
Okay. And it's amazing that slow-paced breathing can achieve that kind of outcome. If I do slow-paced breathing, I will worry less.
Right.
And, it's not surprising. Lots of we support a number of organizations that do work in sort of the mental health, and we see sort of breathing interventions as a great way to get you out of a really stressful response.
Absolutely.
But we don't see daily breathing interventions at 10 to 30 minutes being part of the script, to really get people sort of sustain change.
Exactly.
Yeah. But it works.
Yeah. I mean, this is what we've been building up to, let's say.
Yeah.
And as the data comes in, it just strengthens our conviction that this may be a very low-cost, beneficial intervention that has a low barrier to participation.
Yeah.
Like I said, we've done the studies in younger and older participants, and no real difference in their ability to comply.
I see. That's a really important thing. Have you actually looked at how at people's sort of self-report of feeling better after the intervention? Is that something you've explored?
So the immediate after effects are have been looked at to some extent.
Yeah.
But my colleague Sylvain Laborde tended to show that the effects were greater after you have completed, let's say, the sustained program for a while.
Yeah. Okay.
So you may or may not feel any immediate effects immediately after.
Got it.
But so one should not be discouraged if they don't immediately feel instantly like on cloud 9.
Yeah.
But know that this is a cumulative.
Yeah. One thing, when as I've sort of inquired more about HRV and started mucking around with using cameras actually to detect HRV, because right now, up to now, HRV measurements have been the domain of watches and bands and kind of expensive wearables.
That's right.
And just now, both you and I have been experimenting with the using a much more cost-effective way of capturing it, which is the selfie scan on the face and so forth. We sort of we see lots of variability across people's different HRVs. Some people in the 20s, some people in the 130s. We know that HRV decreases over time, right? So like younger people have higher HRVs, older people it's a bit lower.
Right.
And
so I have to add,
yes,
there is some evidence that these I can't remember the exact names for these people, but who managed to live into their 90s.
Yes,
their heart rate variability actually seems to be higher, and it may be a survivor effect, or we don't know exactly why. But those individuals in their 90s, tend to have actually higher heart rate variability. So it's not completely linear. It doesn't go completely down. But when you get very, very old, it may actually go up.
Amazing.
Yeah.
Okay, that's really interesting. So when if we were to sort of talk to sort of everyday, so people in say a workplace health setting or something like that, about their HRV, really what we'd want to be doing them is not necessarily comparing with others, but really looking at where there's at and sort of helping people sort of assist with an intervention, knowing that over time they can lift their own, right?
Exactly.
Yeah.
Exactly.
Yeah. Cool. And what sort of size? So let's say my baseline was 30 or 35 or something like that. If I were to be doing these exercises sustained over a 5 to 6 week period, like your trial studies, where might it get to?
Well, we've been able to show that there may be a non-linearity in this function.
Yes.
So we've identified what might be a clinical cut point. So individuals with RMSSD, which is a root mean square successive difference, is a measure of the high frequency heart rate variability.
Yes.
That's below about 25 milliseconds.
Yep.
And they are increased risk for poor physical and mental health outcomes.
Okay.
So it's above 25.
Yes.
Then
you're out of the woods a little bit.
Right.
Yeah.
Your risk is lower.
Okay.
Now, there still is some gradient there.
Yeah, I'm sure.
But the fact that we have identified what may be useful as kind of a clinical cut point, it's just like when you go to the doctor and your target is for your blood pressure is 120/80. Let's say.
Mm-hmm.
And there are different cut points for different levels of hypertension. The hypertension guidelines just came out a couple of weeks ago, and they give you the levels that would indicate your risk and when you should intervene with medications and that kind of stuff.
Yes.
So there are cut points for these types of physiological measures. Up to now, there's been no real cut point for HRV. So that's what we've been trying to.
That's so useful, and I can, in that sort of workplace health context, knowing that if we had people that were screened below that, we've then got an escalation point for potentially further intervention.
Exactly.
Yeah.
Exactly.
Okay. Yep.
So this sort of primary risk assessment, risk stratification, is what we've been doing.
And you mentioned it before, but at the end of the day, any healthcare professional that's looking to help a person sort of improve their health has lots of options available to them. We know that exercise is an option, and yet mental health care professionals don't prescribe it. They're far more likely to reach for an SSRI, and yet exercise is just as effective as an SSRI. And here we have another simple intervention on the table, paced breathing, which again can take people out of from a clinically risky level to to a non-risk level.
That's right. And what's interesting, you mentioned SSRIs.
Yeah.
So we've done the different drugs that you might take for depression.
Yes.
Have differential effects on your heart rate variability.
That's
So
true.
some of them actually may decrease your heart rate variability, which, while it might be treating your depression, might put you in an increased risk for cardiovascular disease.
Fascinating.
Right. So you have to be careful in choosing the drugs that you might.
Can you reveal any interesting ones?
Well, I mean, it's well known that the tricyclics from long ago decrease heart rate rate.
Okay.
And there's different types of SSRIs, and then there's the SNRIs as well. And so they're, of course, developing new drugs all the time.
Yeah.
But each one has a specific effect on the heart rate variability. So you have
absolutely amazing.
Yeah, you have to choose the drug carefully.
Yeah. Okay. Well, that's really interesting. Have a look at my notes. I think one. I mean, here's a little challenge for us.
Yeah.
What do you sort of think is the most hopeful sort of element of your work? I mean, to me, I've you and I've talked at length. I find it accessible. It works in a short time frame. Adherence isn't that hard. The barriers aren't that high. Cost isn't a barrier. I mean, What are, for you, what's the most hopeful part of the research that you've done?
So the fact that, in particular with respect to the Alzheimer's disease risk,
Yeah, okay.
that's kind of we think that this breathing intervention is the first sort of behavioral intervention that's been shown to decrease these risk factors for Alzheimer's.
Amazing. I mean, and by such a big margin, right? Yeah.
So that's kind of, nice, bright, shiny object that we're focusing on these days.
That's so exciting.
And like I said, we've been able to get funding to continue that work with the Alzheimer's disease risk factors, in particular, because the effect in the first trial was so big.
Wonderful. Oh, and that's an area that you and I have sort of talked about as well. Like, I mean, we're sort of we're looking to collaborate on how we can, have a nice, simple intervention that people can do at home,
Right.
That sort of overcomes any potential barriers to doing this, that gives people the guidance that they need, that helps people with their scene setting and the planning and the things that they need to in order to implement something like this.
Right.
Yeah.
No, this is very exciting.
Yeah.
And the taking these assessments outside the doctor's office or outside of the laboratory is really game changing.
Awesome. Yeah.
Game changing.
Yeah.
So the ability to take these measurements in real life settings is quite critical, because as we talked about, the blood pressures that you get in your doctor's office are not all that useful because there's as we talked about, they're often collected incorrectly.
Yeah.
You don't sit for 5 minutes with your feet on the ground. You're sometimes sitting on that exam table with your feet dangling.
Yeah.
The nurse is talking to you. So you need to, the guidelines are that you should be quiet. The blood pressure cuff should be at the level of the heart. All these kinds of things that are typically not done in the doctor's office, so that even those readings are not that useful. So these new guidelines suggest out of office readings to be more reliable than in office readings, for example. So to the extent that getting into real life gives you more accurate measures, then these types of wearables and this type of app is
facial scanning
is game changing.
Yeah. Okay. That's awesome. Well, thank you so much for taking the time and sharing this. It's going to be, fun to share this with sort of some of the people that I work with.
Absolutely.
Chief, it's awesome to have you here and share the conversation. Thank you.
My pleasure.
Awesome. I will wrap that up.